Welcome to my YouTube channel Mechanical Magic Mechanical Learning Tutorials. So in this video I am explaining how to calculating different temperatures, internal energy, work done, amount of heat transfer and change in enthalpy for a polytropic process. So let us see the data. It will be given into the example. 1 kg of gas is compressed polytropically from 150 kilopascal pressure. So that will be the pressure is given to us with the mass. So 1 kg of mass P1 150 kilopascal. So that should be converting into 150 into 10 raised to 3 pascal and 290 degree Kelvin temperature. So here in that case, direct temperature it will be in the form of Kelvin. So T1 equal to 290 Kelvin to 750 kilopascal. So that will be the pressure to 750 kilopascal. So that should be converting into pascal. So 750 into 10 raised to 3 pascal. Then the compression is according to the law PV raised to 1.3 equal to constant. So that will be called as a polytropic process. Find final temperature. So T2, work done, internal energy, amount of heat transfer and finally change in enthalpy. Take the value R 0.287 kilojoule per kg Kelvin. That should be converting into joule per kg Kelvin, and value of Cp that will be equal to 1.001 kilojoule per kg Kelvin from here. First of all, let us see onto the PV diagram this process. So for x-axis that will be the V, y-axis that will be the pressure. So here is the problem for the compression. So 1 to 2 process like this. So for 1 that will be having a V1 volume and P1 pressure and the temperature is around 290 Kelvin. From 1 point to 2 point that will be increasing the pressure P2. So here P1 that will be 150 and P2 750. So this area you can say that work done by the systems, and that will be PV raised to 1.3 equal to constant. That will be representing as a polytropic process. So starting with the first one by the polytropic process. So from polytropic process, taking a relation of temperature and pressure, so T2 by T1 equal to P2 by P1 raised to n minus 1 upon n. So value of n you can find from here. So just put the value of temperature T1, so 290, that will be into 750 into 10 raised to 3 divided by 150 into 10 raised to 3. So you can say just put the value and you will get the answer. T2 that will be equal to 420.4 Kelvin. So that will be the answer number 1. The final temperature. Now I am interested to find out a second one, and that will be the work done for the polytropic process. So in the case of work done for the polytropic process, that will be equal to W P1 V1 minus P2 V2 divided by n minus 1. Just converting that P1 V1, it will be in the form of MRT. So like that, MR T1 minus T2 divided by n minus 1. Just put the value of M, that will be the 1 kg, R 0.287 into 10 raised to 3. Now it will be converting into joule per kg Kelvin. Temperature difference divided by 1.3 minus 1. And that answer it will be in the form of joule per kg, and that will be converting into W is equal to minus 1 to 4.75 kilojoule per kg. So that will be called as a work done by the polytropic process. Third one, change in internal energy. So for change in internal energy, delta U equal to mCV T2 minus T1. But here the value of CV is not given, so remaining R and CP is given, so R is equal to CP minus CV. So just put the value of R, that will be 0.287, that will be equal to 1.001 minus CV. So finally you will get the value of CV, 0.714 kilojoule per kg Kelvin. So just put the value of M, CV and T2 minus T1 and you will get the answer. Change in internal energy delta U equal to 93.11 kilojoule per kg. Then fourth one, amount of heat transfer. So amount of heat transfer for the polytropic process, that will be having equation Q equal to gamma minus N upon N minus 1 into work done. But once again, the finding of the value of gamma and CP is CV is given. So gamma is nothing but CP by CV. So just put the value of CP and CV and you will get the value of gamma, and that will be 1.402. So just put the value of gamma and work done. So work done is already calculated from above data. So just put the value over here and you will get a amount of heat transfer, that will be Q is equal to minus 31.65 kilojoule per kg. And last one, change in enthalpy. So change in enthalpy, that will be delta H equal to mCp delta T. So mCp and temperature difference, so you will get the answer change in enthalpy, that will be 130.5 kilojoule per kg. So that will be the simplest form of the calculation of polytropic process. If you understand, if you like, then subscribe and share Mechanical Magic, Mechanical Learning Tutorials. Thank you.